So the first thing I want you to notice on this worksheet, the title's clever, fancy factoring. It does say in the directions, you're just factoring these. We're not going through and solving them, even though they all look like equations. So for me personally, it bothers me that they are equations. So for me, I'm just going to scribble out this equals 0 on like literally every question. It just mathematically bothers me that it's an equation. So there are certain questions that I circled that I intended to do with you. Can someone tell me the first question that I circled?
1.
Oh, what a plan, number 1. So I'm looking at this and I'm thinking about my factoring process, and I first look for any common terms. 1, 2, 3, 4 terms this time. There's not a single common term between all 4 terms, so I'm stuck using an alternative method of factoring, and the one that we utilize when there's 4 terms in a polynomial is called factor by grouping. So you group the first 2, and you group the last 2, and you treat them like their own tiny factoring question. So this first group, the common factor between x to the third plus 4x squared is a common x squared. So if you take x squared out of that group, you still have x plus 4. Now we look at the second group, and we have to remember the whole purpose of doing factoring by grouping is you want these parentheses to match. So keep that in mind when I ask you what are we going to factor out of the second group. There's not really much in common, but I do notice there's like a negative sign I don't want there anymore. So if I factored out the negative 1 from that expression, I'd be left with the x plus 4 that I need. And then remember, this is all one gigantic problem with 2 terms technically. This is a term and this is a term. So between those 2 terms, I notice there's a common x plus 4. So that x plus 4 gets factored like way out in front of the problem. And then when you remove or factor out the x plus 4s, you're left with x squared minus 1. And then this is where an Algebra 2 student got really depressed because they thought they were done. And then their teacher said, psych, you're not done because look at x squared minus 1. Isn't that the difference of 2 perfect squares? So now you have to go through and factor that again. X squared plus 1 is really x plus 1 times x minus 1. But the x plus 4 does not factor any further. So that, my children, is why I tell you I don't want to see just magical answers popping up on your worksheet. I know the answers are in the back. There's supposed to be work with these problems. These are not a one and done, like, don't tell me I did this in my head, because that's not going to fly. What's the next one I circled?
3.
3. Okay. So, number 3, again, I don't want these to say equals 0, so I'm just going to scribble those out. Oh, x to the 4th minus 7x squared minus 18. So if I think about the factoring flowchart that we saw back in the day, I'm supposed to look for common terms. So there are no common terms in this problem. And it's a 3-term polynomial. So the way we approach a 3-term polynomial is we just reverse FOIL it. But this one's more exciting because when I start off my problem with what times what gives me x to the 4th, there's actually multiple answers for that, but look ahead in the problem. I can split up x to the 4th a few different ways, but I think it would be really brilliant if you guys split it up as x squared times x squared. Because my middle term is going to need to add up to x squared later. And then for all factoring, I always have you guys kind of jump to the end of it. I'm looking for a product of 2 numbers being negative 18, so there's a couple of options for that, like 9 and 2, and 6 and 3, 18 and 1. And we're going to have opposite signs, so I have to keep that in mind. If I look totally into the middle of the problem, I want my arches, those outside-inside arches, to add up to, where is my pen? Negative 7x squared. So keeping that in mind, should I use the 9, 2, 6, 3, or 18 and 1? 9 and 2, and then I have to be careful about who's negative, don't I? So I heard negative 9, thank you. Come on, pen. Negative 9 and a plus 2. And then an Algebra 2 student would be like, goodness, I'm done. But a PreCalc student is going to say, no, you're not, because look at that difference of squares sitting right here. X squared minus 9 is going to factor again. X plus 3 times x minus 3. But x squared plus 2, there's no such pattern that I can factor that with, so you just leave it. All right, let me guess. Is 5 the next one I circled?
No.
Oh man, got crazy. It's number 4 now. So, oh yeah, number 4. Oh boy. Hope y'all had a good breakfast today, because you're going to need it to get number 4 done. X to the 6th. A lot of ways I could break up x to the 6th. But if I look ahead in the problem, I notice I want my arches to add up to x to the 3rds. So that's how I'm going to choose to factor the x to the 6th component. So When I go to ask you what times what gives you x to the 6th, and I kind of spoiled the problem here, and I said we're going to use x to the 3rd, that's what you're going to use. But do you guys understand, like, technically that answer had a bunch of, that question had a bunch of answers. I could have said x to the 4th and x squared, x to the 5th and x to the 1st, but if you look ahead in the factoring question, you can kind of figure out what you need. All right, jump to the end with me. Negative 125. Well, the good news is this is one of those factoring questions where the coefficient is 1 in front, so we should be able to think about both parts of the puzzle at the same time. I'm looking for two numbers that will multiply to negative 125, and then in the middle they're going to add up to negative 124. So what if we did negative 125 and a plus 1? Would that work? Because that would add up to negative 124 in the middle. Good news. And I bet even my pre-calc kids think we're done, don't you? Not anymore, because you just made that face. It says we're not done. Those are cubic patterns, both of them. This is the difference of two cubes, and this one is the sum of two cubes. Okay. So let's see who has it memorized. The difference pattern starts off with a difference problem. So this one, I'm going to kind of jot the pattern up here for you. It's going to factor into a minus b times a squared plus ab plus b squared. And then the sum pattern factors into a plus b times a squared minus ab plus b squared. And just like back on the factoring quiz, I expected you guys to have that memorized, and it still should be in the memory bank somewhere. So here we go. I'm going to call this the blue problem for a minute. I need to factor this blue problem using this blue pattern. So a minus b for us would be x minus 5. And then a squared will be x squared plus, you multiply them together, so 5x plus this guy squared, 25. Remember, on the cubic patterns, the signs are already built into it. You don't have to worry about whether a and b are positive or negative. It's part of the pattern. And then this problem here, let's call that the black problem. We have x to the 3rd plus 1 using this pattern right here. Here we go. A plus b would be x plus 1. And then a squared will be x squared minus 1 times x plus 1 squared, which is just a 1. Lovely. The good news is, once you use the cubic pattern, you are most definitely done with factoring. You can never factor a cubic pattern further. I have a feeling if you look on the back where the answer key is, they probably have the terms in a different order, but we know you can rearrange multiplication terms as however you want, so just be flexible in your answer. Did we get it right? It would be pretty embarrassing if we're wrong, because I'm recording. Are we good? Okay. I bet I circled one more. 7. Oh, yeah. So, back to the top of the flowchart in my brain. It says, look for common factors. So again, I'm scribbling out these equal zeros. We're not going to be solving. This time we do have a common factor. They have a common x that we're going to take out of the problem. And some of us learned the hard way that when you factor out a polynomial's term, if it's not an equation, you're not doing anything with that x. It's just staying out in front. And back in the day in Algebra 2, sometimes that's all you could do to a problem was factor out a common term, but no longer in PreCalc. They're usually more exciting than that. So this problem I kind of highlighted in red here is a trinomial that we're going to factor kind of like we did back on number, I think it was number 3. So leave the x in front. And I'm going to ask you guys for two numbers that multiply to give you x to the 4th, but if you look ahead in the problem, I think you can kind of see the answer here. That's x squared and x squared. And then you need your last numbers to multiply to -6. But remember, you need the middle numbers to add up to 5 at the end of this problem. So, alright, so +6 and -1 would do the trick I'm hearing. Very good. And then, of course, everyone's like, oh, we're done! And then we're like, no, we're not. Because x squared minus 1, the difference of two squares, is going to factor again. So I guess the moral of the story today, guys, is be really careful when you think you're done with a problem. If you see the difference of two squares pop up again, you're going to need to factor again. Now, you guys have the benefit of the answer key being on the back of the worksheet. So I encourage you to, as you finish a problem, flip over and check each time. But are we all clear now what I mean by I expect to see work on these questions? And I'm going to like call you out if you have like magical answers and no work. Don't be that kid. All right. So the rest of it is going to be your homework assignment. You actually have 2 homework assignments tonight, factoring just being one of them. Let's keep this going. Let's pull up in your notes packet. You just got handed a new packet for chapter 2. Ooh. And today is kind of a weird day because we're just going over some skills that we're going to need to move forward in chapter 2. We actually haven't started chapter 2 yet today. So this is another review concept. However, we're going to kind of bump it up. So I'm looking at worksheet 1A. And your textbook does a really good job of explaining to you the official answers to these questions that we're going to do. Now, last year we taught this lesson, and we stuck to the official math rules. So you're going to see things like absolute values in your answer key from your textbook. And you're going to notice that I'm not teaching you anything about absolute values today. Hoffbauer and I decided that, you know, for the sake of your sanity, there's certain components to this lesson that we're going to eliminate. Absolute values being one of them. So if you ever notice, like on an old answer key, like something is randomly put in an absolute value, or if you look in the back of your textbook and you look at the odds and it has absolute value in the answer, just ignore that. If you want to know why they have absolute values, you can read through your book as to why they do. However, we talked with the calculus teacher, and we've determined that that's really old school math approach, and people don't really use it anymore. So to kind of save you guys a little grief in your homework, we're ignoring part of the lesson. So whatever I don't teach you, you don't have to worry about. How's that? All right, so these are key concepts back in the day in Algebra 2 even. You guys learned about what is called a rational exponent and how it relates to a radical. So I always told my Algebra 2 kids that B stood for the base. And then if you wanted to write this as a rational exponent, it was the power divided by the index. So that right there has a lot of vocabulary, doesn't it? So the base, I think you guys can pinpoint pretty quickly. I don't think we're on your notes yet, guys, so we're just kind of covering an old formula. So the base you can pinpoint because it's what's either in the radical or what's holding up the exponent. But when I refer to the power, I'm referring to the exponent that's on the problem. And then do you guys remember what index meant? It's the teeny tiny number in the radical, or outside the radical, excuse me. So like when I draw this symbol, you guys all assume that was a square root, because if they don't put anything in the index, what do you assume is technically there? There's technically a 2 there. But anytime you draw a radical symbol, because that's the most common radical, they just called that a square root. Is there such a thing as a first root? No, there's not. So there's a square root, a cube root, a fourth root, a fifth root, and so on and so on. So, exponent properties look familiar? We're going to be using these today. And then just for funsies, we're not going to just be using any old exponent properties. We're going to be using exponent properties on fraction exponents. So, because these are all exponent properties out of various textbooks, when we get to the moment where I'm going to have you guys do fraction work, like, yeah, you have a calculator that you can do fraction work on if you need to, but I'm actually going to have you do them by hand because it's good for you. And also there's pretty intense tests coming up for most of our friends soon. Oh, speaking of tests, show of hands, is anybody taking the PSAT next week? Okay. It's okay. The next class I think has more kids too. We're going to move the test around so we didn't punish you for taking the fun test. We'll talk about that later. All right, guys, so this is on your worksheet, right? We have the x to the 7/6 power. So they want you to write this in radical form. So you'd write your radical, and then what number should go in the index? Using that little pattern. Is it the 7 or the 6? It's the 6th root. Good. It's the 6th root of x to the 7th power. Now, your Algebra 2 teacher told you you could put the 7th power anywhere, and that is true. For today, could you please put it on the inside? And this is probably where you left it in Algebra 2. Your teacher made you rewrite it in this other form, and then you walked away. Well, no longer, because we can actually reduce this radical. When you have a sixth root, that means things that come in groups of 6 can escape the radical. And what is x to the 7th? 7 x's put together, right? So this is how I want you to think of this question. It is the sixth root, and then we're going to break x to the 7th up. I want you to break it up into x to the 6th times x to the 1st. Can we agree that that is the same thing as x to the 7th? Now, I chose to break it up that way because I know anytime I have sixth root of x to the 6th, this can escape the radical. What is sixth root of x to the 6th? It's just going to be x to the 1st power, out of the radical. But what about this lonely little x that was x to the 1st power? Does that escape the radical? No, it does not, so it stays in the radical. So this problem is actually x times the sixth root of x. They didn't tell you that in Algebra 2, did they? You thought that was a really easy question, didn't you? Okay, so it's a little more complicated. We got to talk about that. All right, so here we have 4x as our base, and it is the cube root. And then this quantity of 4x is being raised to the 4th power. So anything that comes in a group of 3 can escape the radical, if you want to think of it that way. So guys, this is how I want you to rewrite this radical. Call it 4x to the 3rd power, and then how many extra 4x's are left? I only have 3 right now, so I need one more. Very good. So we're using exponent properties, but we're using them in reverse to break apart the power. So this guy right here, this is the one that can escape the radical. This can reduce. The cube root of 4x to the 3rd power is just going to be a 4x out in front. And then what is still stuck inside of the radical? This other 4x, right? So this is a little confusing. What I do in my Algebra 2 classes is I have them use highlighters, and maybe if you have a highlighter handy, you might want to do this as well. But when they do the breaking apart step, I have them highlight, whoops, that's not a highlighter. I have them highlight things that will reduce or break down, or sorry, escape the radical. So like I have them highlight x to the 6th. Over here I have them highlight 4x to the 3rd power, because those are the things that are going to come out of the radical. Anything we don't highlight stays in the radical. This is the stuff in the lesson that we are ignoring. So if you see this, you're going to pretend you don't see that. We got permission from our calculus teacher that we don't need to worry about that business, so we're skipping it. All right, guys, here we have 64 n to the 6th power, and then quantity raised to the 1/2 power. So it's like the 1/2 power, same thing as the square root. So it is up to you guys how you want to simplify this. What I will tell you is I don't really care. If you want to write it as a square root and then think of it this way, that's fine. If you want to use exponent properties, that's fine too. But let's kind of stay consistent maybe with our radical. So I'm going to actually rewrite n to the 6th power as something else real quick. You guys don't have to write this part down if you don't want to, but can y'all agree with me 64 is going to reduce? I don't need to break it apart any. I can take the square root of 64 really easily. And we said for square roots, only things that come out of square roots are things that come in pairs, squares. So can you think of n to the 6th as n squared times n squared times n squared? You don't have to do this step. This is just kind of how the Algebra 2 teachers taught this to you. So when I go to ask my Algebra 2 kids, like, okay, well, what's going to simplify here? They're going to tell me everything. Like, you're going to be able to take the square root of that, you're going to square root of that, square root of that, square root of that. So is there going to be anything left in my radical at all here? No. So ladies and gentlemen, what is the square root of 64? And what is the square root of n squared? N. And then you have another n, and you have another n. So when you have n times n times n, you have n to the 3rd power. So that's your simplified answer. Can we back up to this step though? Do you guys see how you just could have done the power divided by the index and right away got n to the third. So that's a shortcut that I would encourage a pre-calc student to take. Go ahead and divide 6 by 2 right off the bat. When we first learn it in Algebra 2, we kind of break them apart into twins, I think Hofbauer calls them, but n squareds. All right, let's take a look at this one. We have the cube root of 8m to the 9th power, squared, oh boy. I think my pen is possessed today. Here we go. So we have a couple options. Yes?
Number 2, what if you take the cube root of 4 and 4x when you would
So right here. So this quantity is raised to the 3rd power. Does that make sense? Okay, yep. And you see why this one's left over? Got it. I know it's difficult when the bases are multi-quantity. Like if using parentheses helps because you think of it as one term. But yeah, you're right. If it had a coefficient that was cube rootable, like an 8, then we would go further and try to cube root it more. Does that make sense? Okay. All right. So there's a few things we can do here, guys. Me personally, I don't really like powers on top of powers. So what I'm going to do is I'm going to distribute the squared into the 8 and the m to the 9th. So I'm going to rewrite this problem as the cube root of 8 squared is what, 64? And then m to the 18th power. So I'm going to ask my pre-calc students, what here is going to reduce? Can you take the cube root of 64? And the answer is yes. And if you didn't know that answer, you have a couple of options. You got a cube root button on your calculator, right? Do you know where to find the cube root button? It's in the math menu. The other way is just to think really hard. Something times itself 3 times gives you 64. Have you figured out what that number is? I think it's a 4, isn't it? So the cube root of 64 is 4. And then are you going to be able to evenly divide 18 by the index of 3? Sure am. So let's take a pre-calc shortcut and just go ahead and divide that. So the cube root of 64, you guys told me was a 4. The cube root of m to the 18th will be m to the, divide those, 6th power. Very good. If you want to go old school and you want to write like m to the 3rd, m to the 3rd, m to the 3rd, m to the 3rd, m to, 6 times, you go right ahead. But pre-calc, we're always looking for shortcuts, aren't we? Okay, here we go. So another rule that Hofbauer and I decided this year that we're just going to scrap is this part, where it says no fraction exponents in the denominator. We have recently learned that that's not actually a thing anymore in math. So back in our day, when we were having to do these questions, we had to do what's called rationalizing the denominator. But we got word from your calculus teachers of the future that they really don't care about that anymore. So that was wonderful news when we heard that, because if there was one thing in this lesson that would make you go home and cry, it was getting rid of fractions in the denominator. I can show you one for funsies at the end of our lesson. Okay? But for the rest of today and the rest of our year, when you have a fraction exponent in your denominator, pre-calc says that is okay. What is not okay, though, is just like in Algebra 2. When you do exponent work, you can't stop simplifying until all your bases are combined, all of your exponents are positive, and you don't have any more parentheses in the problem. That's kind of the checklist you used in Algebra 2. Same checklist here. So guys, we have some coefficients, we have some x's, we have some y's. Let's start with coefficients. Coefficients are not exponents. They don't follow any rules other than just general number. So 2 times 3, better known as? That's right, class, 6. All right, then exponent rules. Pull them out of the back of your brain here, guys. What do you do with your exponents when you're trying to multiply your bases together like this? You add them. Remember that guy? So this becomes x to the 3rd. And then y to the 4/3 times y to the negative 1/2. You have the same rule here, guys. We need to add these together. Now, happy Wednesday morning to you. We're going to be doing that without a calculator, because if a 9-year-old can do it, that's an exaggeration, a really smart 9-year-old. If an 11-year-old can do it, so can you, right? So let's take 4/3 off to the side of our paper, and you're going to add it to negative 1/2, which means we need common denominators. So this guy, hit this fraction by 2/2, hit this fraction by 3/3. That way they're both out of 6. So 8 out of 6 plus negative 3 out of 6, which would be 5 over 6. So this is y to the 5 over 6. So my checklist for exponent problems. There's no parentheses. Check. All my bases are combined. Check. Are all your exponents positive? Check. So this is the final answer. Okay, let's take a look at 6. Oh boy. All right, so when you have an exponent outside of this multiplication question, this exponent does get distributed to each term. However, each term already has an exponent. Do you remember what we do with these numbers to combine them? Multiply. So here we go. We have -2 times 3 halves. So off to the side in our paper, -2 times 3 halves. This time you are multiplying your fractions together, which means you are either simply multiplying across the numerator and denominator, or you can do a little cross-canceling. You see the little cross-canceling that will happen there? So the 2's will knock out. This becomes x to the -3. Leave it for a minute. We'll come back to that. And then times y to the, here we're multiplying 2/3 times 3 halves. And then in this case, the 3's and the 2's cross-cancel. So you end up with just y to the first power, which I am going to put a 1 down, because we have more terms to come up with in a minute. This original term of x squared y to the -2, nothing happened yet. Oops, except that's +2. So I got rid of my parentheses. That was checklist number 1. Next, I got to combine all my bases. So these x's need to be added together as far as their exponents. So you have x to the -1st. And then same thing here with the y's. You have y to the 1st times y to the -2. So add those together for me. And you get y to the -1 as well. But then there's that third rule in the checklist. No parentheses, everything's combined. And then the last rule is you can't stop until all your exponents are positive. Who remembers the property? What does it mean when you have a negative exponent? Yes, that term needs to move to the other side of the fraction bar. One day a class asked me what a fraction bar was called, so we Googled it. It's called a vinculum. Yeah, keep that in the memory for Jeopardy one day. Yeah, that's a good one. All right, so x needs to move, y needs to move. Guys, there is still something in your numerator. What is still there? There's still a 1, yeah. So 1 over xy is a great answer. Leave it like that. Same idea here, except there's really just one multiplication problem going on. So to challenge yourself on a Wednesday morning, 5/4 times 3 halves. There's no cross-canceling here, so you have a gross 15 over 8. And then times, I'm going to write this as u to the 1st times v to the 3rd. I just really like to separate all my bases. I don't like when they're together. Okay, we're not done because we have to combine the v's. So you need to take your exponents on the v's and do what with them? I heard someone whisper, add. Oh boy. All right. 5th grade. Here we go. You're taking 15/8 and you're adding it to 3 over 1. Well, you can't call it 3 over 1 because you need common denominators. So let's hit this by 8 over 8. This is really a 24 over 8. So 15 plus 24 is 39 over 8. There we go. So this is v to the 39 over 8 times u. You can say u to the 1st. You could put u in the beginning of the problem. I do not care. We all know that's equivalent. Lovely. All right, here we go. Number 8. Oh boy. Okay, numerator's not too bad to look at right now. Let's leave it alone, but I am going to kind of break it apart into u to the 1st times v to the 3 halves. We'll come back to that in a second. But let's talk about this hot mess going on in the denominator. You've got distribution right away. Here and here. And then in a minute, we're also going to have to combine the remaining parts of the denominator. So squared raised to the 1/3 power, we're multiplying those together. So 2 times 1/3 is u to the 2/3. And then -2 times 1/3 would be v to the -2/3. And then we still have a times u to the 3 halves times v to the 4/3. Those are all located in the denominator. Now, in Algebra 2, kids got overwhelmed because there was like literally no way you could mess these up unless you did a property wrong. So when your teacher said, like, what are you going to do next? And then I asked your friend, and it might not have been the same thing you were going to do next. So just take my advice on this, guys. You want to clean up that denominator before we do anything else. That denominator is a hot mess. So let's go ahead and collect the u's by adding their exponents together. And then we're going to do the same thing with these v's in the denominator. We're going to add those guys together as well. All right, here we go, 5th grade. So you have 2/3 plus 3/2. Common denominator there would be out of 6. So multiplying here by a 2, you get 4 out of 6. And multiplying here by a 3, you get 9/6. So 4/6 plus 9/6 is 13/6. Gross. So this is u to the 13/6. This is just in the denominator still, remember? All right, same thing with the v's exponent. We're going to be adding those together. Man, I should have wrote lower. You have -2/3, and you're adding that. Oh, at least those already have common denominators. That's nice. So -2/3 plus 4/3 is going to be v to the 2/3. And then remember, up in the numerator, you still have this u to the 1st, and you still have this v to the 3/2. So I don't have any parentheses, but I do have multiples of each base. So what we have to do next is remember another exponent property. Who remembers what you're supposed to do with your exponents when you divide your bases like this? You subtract your exponents. Very good. So 5th grade strikes again. You got to figure out 1 minus 13/6. All right, so 1 minus 13/6 would be like 6/6 minus 13/6, which would be -7/6. So right now, in our numerator, technically, you have u to the -7/6. And then same property we're going to use for the v's, but this is a 3/2 minus 2/3, which obviously doesn't have common denominator. So this becomes 9/6 when you hit it by 3. And this becomes 4/6 when you hit those by 2. 9/6 minus 4/6 is 5/6. Now, when you guys use that property there of subtracting, your answer always defaults to the numerator. And then some of you get a little jumpy and you're like, it's negative. And then you throw it to the denominator. But then kids do that and then they forget to make it positive. Because we're going to do that right now. You guys see that u to the -7/6? When I subtracted, yes, it is a negative exponent. Now we're going to enact that rule of you can't have a negative exponent, so we're going to move it to the other side of the fraction bar. Now what about the v to the 5/6? Is that moving or is that staying? That one's staying. So we have v to the 5/6 over u to the 7/6. Positive this time. And then for us in pre-calc today, that's a great answer. We're going to leave that. All right. Whew, here we go. Distribution. We're going to distribute -2 to every existing exponent and base. Hi. Fire department's here to say hello to us. So we're going to be multiplying these exponents together. X to the 2 raised to the -2 power. That becomes, I can't even read my own problem anymore. This is x to the -4. This is x to the -2. This is y to the, okay, -2 times -2 will be a +4 now. And then -2 times 5/4 is, do you guys see a little cross canceling that's going to go on? So we got cross canceling here. The 2 and the 4 can cross cancel. They can both be cut by a 2 if you want to think of it that way. So this is -5/2. I forgot where I'm even at. I'm right here, aren't I? -5/2. Oh my goodness. All right. So we have the same issue as the previous question where there's like a mess like all over the place, or 2 questions ago, I forget. I want you to clean up that denominator first, and then we'll worry about other terms. So I'm going to need you to add these up. All right, here we go. -2 plus -5/2. I'm going to need common denominators. So instead of -2/1, let's call that -4/2. So -4/2 plus -5/2 is -9/2. Oh my gosh, be golly. All right, so what am I even on? X in the denominator has x to the negative 9 over 2. I still have y to the 4th right here. This is going to be super easy to read later, right? This is x to the negative 4th. I am still not done. The y to the 4th is fine. Leave it alone. But tell me what you want to do with these x's. Sometimes kids get creative and they start moving terms around. I would suggest you not do that because you're going to kind of get a little weird with the negatives. Can you just go subtract, guys? So we have negative 4 minus 9 halves. Sorry, minus negative 9 halves. That would have been bad. So let's get common denominators here. So that would be like an 8 halves minus negative 9 halves. Now, ladies and gentlemen, minus negative 9 becomes a plus, yes? So negative 8 plus 9 is a 1/2. You have x to the 1/2 now in the numerator, and then y to the 4th in the denominator. Yuck! All right. These are just as fun as you remember, I know. Do you remember doing these in Algebra 2? You hated them. Like, absolutely hated them. Like I said, guys, I don't mind if you decide to grab your calculator when you're in a jam and type the fraction on your calculator. I just wanted to kind of jog your memory about, yeah, we can technically do these by hand. All right, 10's very similar. If you guys flip over to 1B, that's where the assignment, or maybe not. Is there an assignment on here? Can you guys look on your blue sheet for me? What kind of assignment do you have for this? Is it a book page or?
Not at all.
We have none at all? That doesn't sound right. That doesn't sound like me at all.
It says 1A.
1B evens, and then there's like a page 17 thing, right? Okay. So, for your homework, you've got to finish fancy factoring. Okay. Then, on 1B, did you say evens or odds? I'm sorry. Evens. Okay, so the back of that, you got evens. And then there's something called capital P17. Now be careful, in your book, that's from chapter 0. Okay, chapter 0. So not page 17, but like capital P17. So you have to go at the beginning of the book. Can you read me the numbers? Because it's not very many.
15, 19, 31, 33, 35.
Okay. Very good. So technically you have 1, 2, 3 assignments to be working on for tonight. That's why I warned you about not leaving your bookwork from yesterday till today. Because you'd be sad puppy right now, aren't you? All right. Tomorrow we start official lesson for chapter 2, 2.1. And then you have a 4-day weekend, which I don't want you to spend the whole weekend doing your homework. So let's get some of this homework done tonight, guys. Thanks.